Hi, this is a presentation for Autodesk AEC Technology Days for 2015 for Australia and New Zealand. My name is Samuel McAllister and I'm a Senior Technical Pre-Sales Specialist for Building Information Modeling. The agenda to cover for this presentation is going to start with our conceptual and computational modeling tools, including Format and Dynamo. Then look at some of the new features in Revit 2016 and the complementary Revit collaboration tool, aka Project Skyscraper. Then move into our VDC tools and field operation tools in the BIM 360 space on the cloud. And finally finish up with InfoWorks 360 for architects. So in the last 15 years, building information modeling has come a long way. We've moved from desktop-based applications in local area network-based environments to moving across from a design level of detail into a socially shared collaborative environment in the cloud with construction and fabrication ready models that can be used for exploring design alternatives, simulating and behavioral modeling. The wheel here for the building life cycle indicates where we are with the initial design development space, moving into fabrication, and then some of the construction delivery zones, and then finally moving around to energy monitoring, maintenance management, capital real estate in the operational space. Kicking off with the first part of the design intent is Format. This is the conceptual push-pull modeling tool. So with Format, it works on Android devices, Apple devices, and desktop browsers. When you model in Format, it converts the data into what is an AXM file and then translates it into a SAT file and a Revit file that can be used for further construction design development inside of a BIM environment. It's a very simple conceptual massing tool where the BIM data can be reused inside a Revit platform. So in this case, if we're sketching on an iPad, we can export that native AXM file out, convert it to an RVT file on the cloud, and then use the massing tools inside of Revit, such as the wall, curtain walling system, floor and roof tools to convert it into a more detailed Revit model. Some of the themes we have now in Format and moving into the new release of Format Pro are of course the push-pull modeling tool, conceptual energy analysis, the integration with building information modeling tools, real-time collaboration with other users, presentation tools, and then finally design options. Format is a tool that will speak natively to that Revit or BIM environment. So this is again where you have the Format model, you save it to the cloud, and it converts it to a native file format that can be used for other versions. It also exports out to an OBJ file. So if you want to take the data out to say a 3D printer, you can export out a clean OBJ file and then use it to do layering and 3D printing techniques. New in the Format Pro environment, we have solar and energy analysis tools, and this will allow users to analyze the design for shading devices, daylighting, and the solar potential. It will also help users at the early conceptual energy design phases to work through factors that will affect energy usage of the conceptual design. This is a quick example of how we can actually work with the Format data by designing an array of minus huts inside of the web browser version of Format and then bring it down into Revit and start converting it into a Revit parametric model. So what we're quickly doing here is just turning on our conceptual styles that we want to display the model, also converting it to metric. And Format is a very simple tool for just doing push-pull modeling. So we can extrude, draw on faces, push-pull components to sculpt the building in the way we want. When we extrude, we can also do offsets on the inside of that face to create a frame for our window. We can also just create solid geometries, draw on the face of those geometries, and push-pull to create openings. Now in this case we want to start creating windows, so it's as simple as drawing on that face, and then we can select items and move them to where we need to be in our design environment. We also have a great material library as well, and when you bring in the materials you can adjust the scale of the texture mapping to suit. We can also add transparency if we want to create transparent windows, and we can bring in our own customized texture maps and then scale them to the scale that we want for our design. So in this case we're going to do a 1:1 aspect ratio, mirror some of the textures, and get the desired effect we want. There's sun path analysis as well, where we can show the shadows that the building is going to cast. And then finally we want to group these designs, these miners' huts, and then array them within our scene. So very quickly we can copy and paste, or we can array and create instances of that original design. When we make adjustments to the authoring instance, the others change at the same time. We then save this to the cloud, and this will convert into a Revit file for us to bring into our Revit platform. So when we bring this in to Revit, we have a massing model. We can load in typical family parameters that we've used from another project. In this case I've got some wall styles and some roof styles, and I'm just using some of the basic tools to convert the faces into Revit parametric objects. So you can load all these in prior to working in your Revit environment and very quickly work up a conceptual design model. Also on Revit we have new that came out in the 2015 release was the sketchy and jittery lines. You can adjust the graphic options to make it look and feel more like a sketch. And then in the Revit environment you've got more control over a perspective camera view. So we've arrayed the model, and now we want to render it. Now you can render on your local machine, but sometimes that can be quite heavy on your graphics card. So we have cloud rendering, which allows you to render on the cloud, which is typically about 32 times faster than a standard machine. Now what I've done here is I've done a very quick render without using any cloud credits. I just want to see what it's going to look like before I commit to doing a rendering. I can also do some luminance analysis here, where I can measure the amount of light hitting the face of that building. While that's calcing, I can go and render out another render. I want to render out a high resolution render. I want to add an HDR field environment, and I'll re-render that so it's larger, so it can be printed out at A3 or A2. I can also do a solar studies analysis as well, a solar study, daylight study, to see how the shadows are going to cast in the building. And another new tool we have here is Turn Tool, where you can do a little 360 spin around the building. So very quickly we've managed to get a number of views without having to be a rendering expert. And then when we're happy with the views that we've rendered, we can do a fine adjustment to the exposure, and then get the desired look and feel we want, apply it, and when it's done, download it and open it up on our desktop viewer to see the final result. Something that's new, that's just around the corner inside of the Format Pro, is these new advanced modeling tools. And this is going to give you the ability to do some of the modeling that you might see in some other of our programs, like swept profiles or enclosing geometry by selecting certain edges of the model. And then there's a loft type tool for connecting multiple profiles or edges. This is the indication of what you're going to get when you compare Format for free versus Format Pro. So pretty much all of them work with all of the features except for the web browser not working, the Android and the iPad not working with the BIM element and content libraries. It's got to be done via the web browser. But with Format Pro, you're going to get on top of that real-time collaboration, energy analysis, and solar analysis. So moving into what we're calling the computational type workflows, and this is Dynamo. So Dynamo is computational design where you can apply behaviors and logics to a model. You're building a system, not just a model, that's going to have intelligent scripting behind it to drive your geometry. You can rapidly test and iterate and study multiple design options in less time. You can solve more complex geometry tasks, and you can do this with precision and with speed. It also communicates with other applications. So naturally it works inside of Revit. It was released with the Revit 2015 R2 release later last year. It will also drive data within Robot, Rhinoceros or Rhino, Navisworks, SAP 2000, Excel, Google Spreadsheets, and Tabular. This is a quick overview of Dynamo being used to drive the design of a train station. So we have a location here in New York. We'll spin around inside of the Revit model, quick walkthrough. And then we've got the conceptual design here, which is our train station enclosure with different heights for different platforms. Now there's a lot of push-pulling in this design, so we can set it up in Dynamo with these integer sliders to drive the width of the platforms or the canopies. These can also be tied into more complex geometry, which is done via adaptive components. So you can see here we've loaded in an adaptive component into the Dynamo-driven environment, and then when we start to connect up the nodes and then stretch and push and pull that environment, the adaptive components will move based on the drivers or the nodes or the parameters inside of Dynamo. Not only can it drive the geometry, but you can also look at color overlays to analyze your model. So in this case we're looking at sun coming into the canopies in this design. So we can do this color overlay driven by an Excel spreadsheet. We can bring this into our Dynamo environment, and then when we run our sun azimuth and altitude path over the model, we can make more informed decisions on how much light is coming into the building and how big these openings should be. You can also schedule out all the components of that Dynamo model. So we've got all our roof schedules, all the panels, all this information can be scheduled out, and Dynamo can be customized to suit different types of workflows in your computational design environment. For more about Dynamo and what our developers are doing, we have Zach Cron and Matt Jizik, who run the Dynamo team based in Waltham, and they do a blog called buildsblogspot.com, and there's some really incredible stuff here, including tutorials and sample files, well worth checking out. A quick example of one of the demo datasets that ships with Dynamo. This is an example of an admin building for our mining site. And what we can do here is we can sketch out a couple of splines. We'll fire up Dynamo. So this is part of the R2 release in 2015. And we'll open up one of the DYN files. And this is the Dynamo script files. And we'll just use this simple script to drive a structural frame in this design. So we have the 3 nodes connected to those 3 lines, and then we have a couple of adaptive component families in here. When we run that script, you see it instantly work with the lines and the adaptive components, and as we reduce the amount of numbers inside that slider, the structural components will reduce. When we stretch the lines or the splines inside the model, the adaptive components will follow those lines. When we increase the number of components, again it adjusts. Now let's say the client wants to look at a different option, move away from curved roofs and moved into more of an A-frame type structure. We simply switch over the adaptive component and keep the script running. There's a lot of adaptive components within the design, so we run that script and instantly the design is changed to suit that new truss. So moving into Revit 2016, the core thing behind these tools is it's much better at sharing and collaborating. It's a lot smarter and a lot faster, and it produces the draw calls as needed. So this is an example of 2015 up against 2016, and this has been done on a standard laptop, and they're just testing the graphics and how the computer is pulling, or how the software is pulling what's called draws to do the command. So as we're spinning, we're panning and moving around the model, you can see that the 2016 is a lot faster than the previous 2015 version. If we need to crop or add section boxes or reduce section boxes, again, this information is being pulled out a lot more quicker. And what's to know here in the 2016 version is we're adding a lot more tools to populate the model with fabrication and construction components. So this is the data set that we do a lot of testing on. This is the Sarang Church. This is the Korean mega church in South Korea. And here's an example of that church being tested in Revit side by side against Navisworks. So you can see that the 2016 Revit is pulling or drawing the information just as quickly as our standard Navisworks. Moving into structure, the tools now allow you to pull in a lot more information quickly, but when you zoom out from that information, it's going to reduce the amount of geometry you see. So on the left here is a 2015 model where you see all the rebar hidden inside that concrete work. But when you're zoomed out, you don't need all that level of detail. So you can see here on the 2015, it's not pulling down all that information. It's just giving you a very schematic diagram of the model. It's not drawing up all the geometry. So this means that you're going to be able to zoom and pan like those first few images a lot quicker and navigate around the model. Also on subscription, there are a lot more apps that you can get for Revit. These are just some of the ones for structure. We've actually got a filtering tool in the Revit Exchange now. So when you want to find something, you can tick on categories for structural design, maybe subscriber only apps, and then bring up some of the tools that you can get as part of your subscription. So in this case, I just want to look at the frame generator. And what we can do here, because this is for the Australian market, we're looking at loading up the database for the Australian AusPro section steel database. And we can bring in all those steel components into our Revit structural environment and use the frame generator tool to start building up something like a basic warehouse design. So the quick workflow here is you go to your extensions. There's a number of subscription tools that you get as part of your subscription that you pay every year. And we can load up all the components we need to drive this build of this warehouse. And you can see here, once they're all loaded, you've got hundreds of different steel components you can choose from to add to the columns, the trusses, the purlins, the bracings. All of this is ready. It's all the correct content for that particular country. And we can go through and add our final bracings, choose the type of bracing we want to have at the different spans in our design, add the number of purlins, and then finally hit OK, and instantly create a structural warehouse. Now, it doesn't do connection details inside of Revit. This is where we have advanced steel to do steel fabrication details. So the workflows that we have is we can have a bidirectional workflow between both Revit and advanced steel where we can sync the data between the two. So one of the examples we have here is where we're adding, say, more components. This is our Revit model that's been synced into advanced steel, and we're adding some handrails, or perhaps we're adding some stairs. And you can see inside of advanced steel there's some really strong detailing tools for doing handrails. When we go to export the data, we can export out the changes back to Revit, so it's a GTCX file. Then when we come to import it back into Revit, we're going to sync it. So when we go to the synchronization and bring back in that GTCX file, we can go and choose the components to bring back in. So we can clear all and maybe just choose the modified components. And we can apply these filters to bring back only the changes that we need, things that have been added or adjusted within the advanced steel platform. And here we have the beams and the railings that we've added inside of advanced steel back inside the Revit environment. So new for 2016 Revit is fabrication and detailing for MEP. So this is going to enable our existing MEP fabrication customers to start working in the Revit environment collaboratively with the Revit architecture and structured applications to produce more coordinated models. So what you're going to see when you open up the 2016 version of Revit is the fabrication part library. And you can fire this up and it's going to come with the UK and the US fabrication database. But you can still load up your own database for your particular country. So all of these tools from CAD MEP and estimation and CAMDuct, they're going to start featuring inside of Revit 2016 and onwards. So this is where you can now work with actual real-world components. So instead of working with a run of ductwork, which might have 8 fittings for a design intent model, you can move into working with construction components, which you can reduce it to say 3 fittings. So a quick snapshot of the fabrication parts properties. So when you open this up, bring it into your model, you can go to the properties and you can edit information in that part. And what we're seeing here is how easy it is to start using these fabrication components inside of a Revit MEP environment. So it's very quick to connect up those details, connect those systems, and work with actual real-world components. And then when we're actually running a length of pipe, it's got the same type of rotation tools as you see within Plant, where you can start placing stuff in 3D and automatically rotating around to run that spooling. So all of these components that are now loaded into the Revit MEP environment, they're procured components with realistic dimensions from manufacturers, providing more confidence that the as-built data or the as-built models will fit within the spaces and the services zones in your design. This is also an example of adding duct hangers inside of your run of ductwork. You can see the parametrics, so as you move that ductwork up and down, the hangers are going to move with it. We can also send those points out to point layout. So what we can do here is we can export out the GTP data. That's the points where those hangers are going to be drilled. We can send that out, and that can go out to a total station, and that can be used for doing your setting out of those hangers in the real world site. So not everything is inside of the Revit MEP environment. There's still the fabrication workflows. So you can see when we go to do our estimation and work through our CAMDuct for doing our nesting and then sheet cutouts and the laser cutters and plasma cutters, you send it out from Revit for that final stage in AutoCAD environment. Just a reminder for anybody wanting to get localized content, the BIM MEPLs group have been building up a fantastic database which you can subscribe to get manufacturers content for your local environment. Okay, so moving into the new collaboration feature for Revit. So this is where we look at moving from locally collaborative to socially shared. So at the moment, a lot of people are working in a decentralized way, sharing data across multiple different storage factors. And this is causing friction between different stakeholders. There's inefficient feedback when we loop the data between one and the other. A lot of this feedback happens outside the tools. So what we have on a typical design project are designers and engineers, contractors, owners, vendors, and then people maintaining the building during the building life cycle, sharing data in different file formats, and then adding more information, whether it be markups or emails or issues and meetings. And what we're trying to do here is use tools which are A360 tools for sharing all this data in one single source of truth. So we have Revit Skyscraper, which is now Revit A360 Collaboration, where we have built-in accelerators so users can share the data directly via their desktop application via accelerator to a central server located on the cloud. This allows not only the authors to share the data via Revit, but also the non-authors, the other collaborators, to share it via A360. So we have a number of firms, multi-firms concurrent authoring, whether it be in terms of model authoring or doing markups or project members or project team members. We have the benefit of no IT setup required, and the BIM data is directly accessible to our other services such as the AWS, the Amazon Web Service, for doing calculations. The cloud work sharing, it pushes the first initial file to Skyscraper, to the cloud, and then there'll be a local copy on the user's machine, the cache version. And then as that person makes changes to that model, it does delta caches across the accelerator to the cloud model. So it's not setting up the entire model at the same time. At the moment, it's a high trust workflow, so people can get in there and delete your models if you have signed them up on the site. And it is a live link workflow as long as you're syncing those models to the central file, and then you can push them out to the A360 site. There are non-Revit links that don't go through, such as linked CAD drawings and materials. These would have to be stored on-premise for them to work with those Revit datasets. And this is a quick demo of it being set up directly from Revit. So as before, in that graphic, the IT guys don't need to jump through hoops anymore. We can collaborate either within the network or via Autodesk 360. We'll sign in, Skyscraper username, and then we can choose a project, a hub, an A360 hub for us to initiate that project to. So by default, it's creating some work sharing, some default work sets. So just be your grids and your standard work sets, and then it publishes it and creates a local cache model. We also have the team users as well, and we can start to display other users or invite project members from the Communicate tool to join that collaborative environment. So Revit at the moment is not really suited for communication within the product. We've tried to pick up a market precedent here, so picking up things like Link Communicator and Messenger to allow us to start communicating inside the product with direct chat, screenshots, contextual awareness, and also work sharing activity feeds. It's not just Revit data that we're putting up on A360, it's numerous file formats that will be accepted and will be readable on the A360 team. So all these different file formats are readable, they can be pushed around the wheel from conception to completion and then read in the one single source. And then we can do push notifications to let people know when items have been pushed to the cloud. So 360 is not just for BIM models, it can be used for digital engineering, civil. This is an example of the data set, the house data set that ships with Revit. We can go in here and you can see, get an idea of the graphics. We can make comments about the design. Maybe you're sharing this with a client and they want to change the specification on the interiors, fittings and furnishings. Or somebody who's doing the glazing in the model has found some issues with the detailing here that needs to be reviewed. We can also click onto those review notes very simply. We can download the model, the RVT model, directly from the site. We can see the published sheets as well, so it's not just the 3D model but the sheet files that have been read. And then we can do a search through the model, and we can search for, say, a material type, and it will go through that model and find all the components with that material type. And the longer you leave it, the deeper the search becomes. If you can't instantly find it, we've got a great little tool here that allows you to do explosion of the model, and you can pull every single component apart, find the component you want, right click and focus on that item and zoom in. So with Skyscraper, we have the users who are working in the mechanical, electrical, plumbing, structural, architectural space. There's the initial version that translates through onto the A360 Team Hub. The initial other users can read it on the 360 devices. Then there'll be the initial sync to centrals. When they sync to central, it will go to the Revit Collaborate environment, but then you have to push it to A360 should you want it to go into the Team Hub. So maybe we've done 3 sync to centrals. We can then push it into the A360 environment, and we can see version 2 has appeared. The users go through, make changes, make their data changes to the design, push through to the 360 environment, the team environment, and then this will come up as version 3, and so on. So in the 360 glue and field environment, you can push your models directly from your data authoring environment, such as your Revit or your Navisworks or your AutoCAD platforms, and then merge the file formats on the cloud. So very quickly the model comes through. You can navigate through the model just like in Navisworks, where you have this avatar and you've got gravity and collision and crouch. You can see your activities and track them. And you can run clash detection. So the clash detection tool will allow you to pick up the models that you've merged and all the components within them. You can select the items that you want to clash, give them a tolerance, and then run a clash report. And then when you click on each item in that clash report, you can then do your markups, add notes, and then do email push notifications to other team members with those comments. Also, the data transfers onto the iPad. So you can see here we can read BIM authoring data even in the iPad environment. So if we're looking at that particular component in the bathroom, or if there are missing parts of the model or there are changes on site, we can do field markups with the pen tool and then email team members. In BIM 360 field, this has been used very heavily by contractors and subbies doing their operations on site. This is an example of, say, someone who needs to be installing and troubleshooting standards for steel, doors and frames. So we can load up our drawings and our PDF data, sync it to our iPad, and then we can be out on the field going through and doing our particular tasks for the installation or the checking or the QA QC of those doors. So there are sample checklists that ship with BIM 360 field which you can use. You can load these up, and this will allow the user who's on site to go through and check all the issues and sign off whether they're approved or not approved or not applicable. So in this case, we can take photographs, we can bring up those PDF plans and mark up items that we're reviewing. There can also be links to the supplier's website. We can create these issues and then assign it to a contractor. So in this case, we've got a draft, open, completed, approved. We can assign it to Martin Ryle Construction, put a push pin in that door and say it needs to be addressed. We can also capture information on the site. So we can add this information in the form of parameters inside a spreadsheet, and then that site information can then be pushed back into Revit via the equipment properties. So a lot of this field data is being captured and then pushed back into the as-built model for FM or operation and maintenance handover. Okay, finally, InfoWorks 360 for architects. So why do architects need this tool? Well, a lot of architects design public buildings and public spaces, and they need to communicate that to all the stakeholders, the communities, and the planners, what the impact of that design is going to be within the context of a city. So if we look at the 360 model builder here, we can use this tool when you start up InfoWorks 360 to actually capture site data to build up a city context. So this is a quick workflow showing how that would look. So we'll start off in America. We can pick our country, zoom into, say, Sydney, and we're going to start off with the Sydney CBD and just draw a rectangle around the zone that we want to capture, give it a name, and then finish it creating the model. And typically what this will do is it will send you an email later once it's actually pulled the data from the cloud, and then you can open it up in your InfoWorks 360, download that model that's captured all the data, save it to your network, and it should only take about 15 minutes to do everything from go to woe, and then open up that model once it's completed. And what you'll see here is it's captured a lot of information with regards to roads, aerial imagery, information on the water area, and some information on the bridge. The harbour bridge in the Opera House isn't quite right, but this is a good basis for starting your city context. There are third-party companies which can build up context for you. This is what we've done with this particular model. But there are various ways where you can grab data from other sources, like you can bring in your Revit models, SketchUp, 3ds Max Design, Bentley models, and you can start to build up certain components using the in-product tools inside of InfoWorks. So if we look at a road design here, we can simply draw an interstate. This is the Kaho Expressway, and then we can use some of the tools inside of InfoWorks to start customizing that design of the road. So we've got some barriers here with the spray paint on them. We can also bring in some vehicles, and then we can use some of the spacing tools and spacing offsets to adjust them to run on this dual motorway that we have here. We can also bring in numerous vehicles. It doesn't have to be just one. We can bring in some buses. If they're positioned 90 degrees, we can rotate them. We can give them much larger spacings, and again offset them so they're running both forwards and backwards in those double driving lanes. And then finally, we just don't want to have just one green car or one bus. We can add maybe a dark green Jeep Cherokee here, and we can give it different types of spacings and offset them a little bit. You can see here there's a bit of tailgating going on, so we can just drop it back a little bit. And now we have our conceptual ramp flyover. So when we go back to our model, and we can go to our properties and update or flip over to another property. We just did the default one to start with. We then have our motorway. There are thousands of models out there on Google 3D Warehouse. So these are SketchUp file formats. There are hundreds for Sydney, and you can download this for free. So this is a great way to start building up the context of your model. You can even get an A380 Airbus. What I recommend is using tools that you get in the suite just to tidy them up before you bring them in. So you can check them all, make sure the textures are right, and then save them out as a DAE file. This is a collator file, and you can bring this in, and it comes in pretty much nice and clean. You can preview it. In this case, this one wasn't modeled quite right, but you can bring it in and then hopefully not crash it in the harbour. But you can bring it in at the default level, then edit it and move it away from the city towers onto the standard flight path that most planes have when they're coming into Sydney. And then finally, I just want to touch on the Revit workflows. So in this case, you know, if you're designing a tower in Sydney, it needs to be pretty sharp, has to be quite prestigious. It's going to be, you know, part of an iconic city front. So we're going to do this conceptual adaptive component model where we're doing a curved facade, and we've got this adaptive component that adapts to the shape that we've modeled in Revit. A lightweight model, doesn't have to have a huge amount of detail. We're just looking at it from a planning perspective. We can go and choose a building that we want to demolish in the waterfront. Let's get rid of that AMP building, and then go to our data sources and navigate to our Navisworks model, which was saved out in this case as an FBX, and we can preview it and do interactive placing. Close and refresh, and now we have a model. Now it's not facing the right way, but we can simply rotate it and scale it to get it to the rough height we want. And now we have our conceptual design placed within context. And then from here we can check things like verified views from several locations around the city to see how it looks in context. And then we can also look at our graphics, where we can look at sun path and shadow studies. So we'll just adjust the graphics here with the field of view, and then go to our sun and sky, and then adjust the time and the date to see how the shadows are going to cast from that design proposal. There's also the ability to look at cloud cover and wind speed and wind direction, and you can speed this up and slow it down as need be. Finally, we've got a great storyboard player inside of this application, which is dead simple to use. You just create snapshots and then link the path together, and you can do fly around animations like this. These aren't rendered, this is just a screen capture of how it looks inside the product. If you want to go further, you can render them out and get sharper quality, but for the sake of this demo, this is pretty good. You can work through design options as well, so we can do one design tower option, and then we can do design proposals where we flick to look at another design proposal from the exact same verified view. We can pick up several views all around the city, so we can instantly see and communicate to others the impact that that building will have on the city skyline. And we can use this tool to do a sort of a theme analysis where we can do this color overlay to show the buildings that are within certain heights, and we can see here our building is really pushing it at the front there. It's moving well beyond some of the buildings which are dictated by the yellow color. And finally, something that's kind of new here, we're just playing around with the ability to translate data from 3ds Max Design to InfraWorks. So these are the populate people that ship inside of 3ds Max Design. If you export these as a DAE file, just with the standard settings, the data, the animated data within them will transfer into InfraWorks. Now this isn't a perfect workflow, but when we load in that DAE file and just look at the preview, you'll see that the paths, the people will follow those paths. Now I need to do some bit more work with the textures, but you get the basic principles. So if you want to start animating components within InfraWorks, you can bring in data from other sources, and it's going to read that information. And so we're just rotating and moving the people around, and now we have an animated path inside of InfraWorks. So that concludes the presentation. So just to recap, we had conceptual design and computational design with Format and Dynamo, the ability to do more collaborative and fabrication or construction workflows in the new Revit 2016, the VDC and field operations within the BIM 360 cloud applications, and then finally we looked at some master planning for architects with InfraWorks 360. Thank you.